we know that pellet quality has, and good pellet quality has very important downstream impacts, on animal performance, in particular when we're looking at our monogastric animals, pigs and poultry. Poor pellet quality and high fines, can reduce feed conversion and lead to, inconsistencies in nutrient delivery to the animal, because the pellets are meant to be, full packages of homogeneous mixture of nutrients. And if we have a lot of fines, then we're not delivering that.
Welcome to the Poultry Podcast Show. Today, I am here with Dr. Jennifer Ellis. Welcome.
Hey, thanks for having me.
I'm really excited to talk to you today about, I'm just going to call it AI and pellet milling, using some automated methods to determine pellet quality. But first, I want to hear, how did you get into the poultry industry?
Yeah, so my background, I'm an animal systems modeler, actually. And so actually, I've been very multi-species. When I did my PhD and my postdocs, I was mostly focused on ruminant species, and then I actually got hired as a animal systems modeler for Trout Nutrition, and I went to work for them predominantly on their poultry modeling. So I got into poultry that way, and since returning to academia, poultry modeling has become part of my portfolio of what my lab does, actually. So since about 2016 or so, I've been working on poultry models.
That's awesome. Well, we always have problems because of the high volumes. So we definitely is job security for you. Oh.
Trout Nutrition North America. Everything we do is driven by passion and backed by science. We support producers in accelerating their journey towards sustainable food production by understanding their challenges and bringing tangible solutions. Trout Nutrition gives our clients access to extensive knowledge, expertise, and resources. Our team of trained advisors is proud to offer on-farm services backed by global research and industry-leading innovation. We go beyond feed. We are dedicated to supporting success together.
So over, the past since 2016 or so, you've been working in pellet technology, maybe just overall modeling for different feed mill systems. Can you tell us a little bit more about what you do?
Yeah, so maybe I can start actually and just tell you how I got into this specific project, if that works.
Yeah.
So I was working, as I said, I was working in industry as a modeler, and was running some nutrition trials at the Trow's commercial mill. And I was running some trials on feed manufacturing conditions by ingredient choice. I was making the diets. We were going to feed them in a semi-commercial setting, looking at animal performance, et cetera. And in the end, my diets were completely confounded with poor pellet quality in the mill. So the experiment itself was garbage, and we couldn't really draw any good conclusions from it. But as a modeler, I was sitting in this mill and looking at it and going, this is, a big data machine I'm sitting and looking at, and boy, would machine learning be a great tool to apply here to try to predict and understand outcomes like pellet quality. And so the idea was born then, actually. And I later returned to academia into my current role, and a collaboration with Trow was actually one of my first projects that I undertook. And we said, okay, let's do this. Let's build some models in a commercial setting to try to predict pellet quality, because, in a commercial setting, there's so many different things happening in the mill, right? There's formulation changes, there's ingredient and nutrient composition changes, there's manufacturing condition changes, and there's even temperature, changes to the outdoor environment and the air that's being pumped through the mill. And so this is a really complex system that's difficult to piece apart and really understand all of those complexities. So it was really a perfect kind of scenario to try to apply machine learning to it. So that's how this project was born, actually.
Yeah. And I mean, consistently, from my very 30,000 foot view of understanding feed milling, it's this pull between speed and quality. I mean, getting what you need out the door, but also in an acceptable format. There's a lot going on.
Yeah, absolutely. You're right. It totally is a push and a pull, because to the one angle, we know that pellet quality has and good pellet quality has very important downstream impacts, on animal performance, in particular when we're looking at our monogastric animals, pigs and poultry. Poor pellet quality and high fines, can reduce feed conversion and lead to, inconsistencies in nutrient delivery to the animal, because the pellets are meant to be, full packages of homogeneous mixture of nutrients. And if we have a lot of fines, then we're not delivering that same nutrient consistency to the animal. So there's lots of downstream impacts on feed conversion. So we want to maximize or optimize pellet quality. But you're right, on the flip side to the mill, there's mill efficiency and economics and even CO2 emissions that come into play at the mill, where we're really playing with a trade-off between oftentimes speed and then the pellet quality. So I often say, because we often talk very casually about maximizing pellet quality, but it's probably more a game of optimizing it, right, against mill efficiency, and also to the other extreme. If we produce super hard pellets, maybe this is not actually optimal for the animal either, in terms of digestibility. And so it's a very complex system, but I think it's really an optimization game. And I think modeling is really nicely situated to help us make decisions in that kind of complex system.
Yeah. So I have a lot of questions just around the modeling, but is artificial intelligence and machine learning able to be used interchangeably, or there different definitions for the people who are in the field versus, me as an outsider?
Well, I think we can review some what these things mean, and my kind of philosophy, and no matter who I'm talking to, is these terms get so much hype right now, but it's not magic, right? It's just it's math and computer programming, right? But it's not magic. So we need to really talk about what it is, so that we can actually understand where its strengths lie, right? So you can think of artificial intelligence, really like an entire knowledge field, like science or something like that, right? And so within AI, we essentially have tasks that normally require human intelligence, things like visual perception or speech recognition or decision making, right? So that's that. So AI is kind of the really broad umbrella. And within that, we have machine learning. So machine learning is a subfield of artificial intelligence. And machine learning is really the process of training and developing algorithms on data, existing data, to be able to make predictions on new and unseen data, right? So it's nothing more than some kind of mathematical algorithm that's going to get trained to detect the patterns in a data set and then be applied to make predictions on an unseen data set. So machine learning itself, right, it represents dozens of different algorithms and different approaches. So it's not a single methodology. There's a bunch of different algorithms and techniques that you can use under that banner. Of course, one of the big ones in there is things like artificial neural networks, which try to mimic kind of the structure of the human brain with a bunch of nodes, and hidden layers. And then we get down into the things like deep learning, kind of as a derivative of neural networks, where we take that neural network and then we develop multiple hidden layers where it can really start to detect patterns that maybe we weren't necessarily aware of, right? So, so there's lots of really interesting things happening in this field, and I think it's really interesting to note too that many of the algorithms that fall under, AI or machine learning have actually really been around for decades, right? So it's not particularly new, but I think what's really new and exciting right now is that because of this, agriculture 4.0 and the big data wave and everything, and the digitization of many systems, including agriculture, we have these data streams that are now available to us, which, similar to the feed mill, are really optimally analyzed via those types of algorithms. So I think what's really new and exciting right now is this partnership between this approach, and now these big data streams that are now available to us that probably can't be easily analyzed via conventional means, on our computers and things like that. So that's the real innovative thing that's happening now, is that partnership and letting us to get more value from the data that is coming off of farms or mills or whatever it is.
So out of all, there's probably a lot of places you could optimize in a mill that maybe with the data you would not have the ability to at the same scale without using a version of AI and machine learning. How did you pick just one aspect? Was it hard just to say, this output is pellet quality and here are the upstream processes? So how did you isolate what variables you wanted data from? Because wow.
Yeah, great question. I think the idea of let's look at pellet quality really came from this botched experiment of mine. But since then, we've been continuing to collaborate with Trow, and actually now we're collaborating with an additional 3 feed companies on the project as well. But it's kind of opened up the idea of there are many other things at the mill, right, that we could be looking at. Mm-hmm. And I think in the future of this project, we will definitely tie in the efficiency of the mill piece. Right now, we're just predicting pellet quality, but obviously, efficiency is the flip side of the coin a little bit. So I think looking at those two things together will be where we go in the future. But in terms of what data do we need? It's a great question. We definitely, took a page from all of the great research that's been done in the academic literature to get an idea of what kind of variables do we need to collect. And the first, so I should also say here that all of this work has been conducted by my former PhD student, Jihao Yu, and he's now my current postdoc as well. One of the first things we did when we started the project is we collected a database, or we collected data from the mill that was essentially available via writing it down on a piece of paper from the mill software. We did this for about 8 months before we ended up collectively having a conversation that this maybe wasn't sustainable. And so the mill underwent some adaptations essentially to automatically capture all of that information that is kind of just going through their mill software, but not necessarily being saved anywhere. The first real project was, can we automate that data capture so that we essentially have files accumulating that we can analyze? But in this first, we call it our pilot data set that we had about 8 months of hand collected data, and it included some basic manufacturing information like conditioner speed, conditioning temperature, speed, et cetera, some basic major ingredients in the diet like corn or wheat or bakery fat, et cetera. And my student had a really creative idea, which panned out in the end, which was he also took regional temperature and humidity, or regional temperature data from a weather station that was close by to the mill, to get an idea of things like what was the temperature outside. Is it the middle of January and it's minus 20, or it's plus 30 in August? And so we ran this first batch of models, and it was really interesting because that regional temperature value actually turned out to be one of the most important variables in the data set in predicting pellet quality, which we were surprised about. We were really surprised to see that. And so we had a few theories about this, or ideas about it. It's very possible, when you build a machine learning model, it's based on correlations, right? So it's not always causal relationships that it's detecting, but it is detecting something, right? So we thought it could be a metric of maybe a difference in ingredients or ingredient composition that's being selected in the winter versus the summer. It could actually be the temperature and the temperature of the air that's getting pulled across the pellets, for example, during cooling or things like that. We thought that was a really interesting observation. When we expanded the project and automated our data capture, we ended up placing a bunch of temperature and humidity probes throughout the mill to kind of try to get a better sense of this variable. Plus, we collected a ton more information on the formulations and the ingredient composition. That temperature and humidity variable has stayed through all the different versions of the model that we've built. And we think it's very much related to this kind of, the temperature of the ingredients that we're pulling in and the temperature of the air that's getting pulled across the pellets. But this is something maybe not as conventional that we found. We did find a bunch of other, variables that were important for pellet quality as well, which might have been expected. And maybe one or two surprises in there too. Like, for example, we know from the scientific literature that the free fat or oil that's in the mixer impacts pellet quality. Mm-hmm. But in our models, actually, fat didn't come up as important at all. Oh. We were really surprised about that until we realized that one of the mill actually already has limitations on the amount of fat that goes in the mixer. And so this is one of the challenges or maybe caveats with using machine learning, right, is that it's going to build the model on the type of data that it sees. So if it's never seen an extremely high fat content in the mixer, it's not going to know that that's an important variable for pellet quality. So in these models, fat did not come up as important, but it's because it's never seen a high fat value, right? So I think this is an important message about machine learning, right? That the models that you develop are really dependent on the data and the type of data that you develop it on, right? So if it never sees high fat, it's never going to know that that's important, right? Which is counter to our kind of our understanding of what impacts pellet quality. So we did a little bit of fishing in terms of what variables we think might be important. Took a lot of inspiration from the published literature, but really it was also just what can the mill collect? What kind of information can it collect in a commercial setting? Because we wanted the models that we built to be able to run in a commercial setting. So it had to be built on the data streams that it had available.
Is the goal to develop each mill have a particular model, or is the goal to have what you develop be applicable across, let's say, all mills in a region?
Yeah, this is a great question. So we started off with building the models at one mill, right? And so similar to the statement about that the models are data dependent, right? We also had this question of, will this model work at any other mill, right? And we don't know the answer to that question yet, actually. But what we are doing now is, kind of based on this project that we started with Trow, and the knowledge that we've kind of gained is we're now expanding the project. So we now actually have 9 mills within Ontario enrolled and participating in the project from across 4 feed companies. And what we will do in this, so we call this the PDI 2.0 project. We will build mill models for each individual mill, but we'll also see if we can build a generalized model that might be applicable across all of those mills. That will bring unique challenges in terms of, seeing what is kind of compatible with what, in terms of data streams. Mm-hmm. But the idea is really, can we build a more robust model by exposing it to more variable data streams and more variable types of formulation or manufacturing conditions? Can we build that knowledge into the model aside from what it would see at one single mill? So this is what my postdoc is working on for the next year and a half, actually. So,
that's so interesting. So you're kind of in the thick of the models and building an application, but I mean, do you think that this is the right path forward? To me, it seems like totally viable and really, really cool. So do you think machine learning needs to be used here and maybe applied elsewhere once you kind of figure out a pipeline, if you will?
Yeah, I think, machine learning and AI is definitely the new kid on the block. And I think there's a ton of opportunities. I think we're in a phase right now of just universally across the industry trying everything. Machine learning is the new toy. So, we're going to kind of throw everything at the wall and see what sticks. But I think in order for, to me, any kind of digital tool or model to be really useful, it has to start from a problem, right? It has to start from kind of like a need point, and work backwards to like what the right tool is to address that problem or that need. So for the case of the feed mill, I think it's a great tool to apply it, because with all of the intricacies in the mill, and all of the things that are changing, we might not always need to understand. Oh, people might not like this, but we might not always need to understand the exact mechanisms, but we need to be able to predict it so that we can make management decisions based on it, right? So to me, you have to start from a problem and work backwards to the tool. I think for this problem, this is a good tool.
Yeah, I agree, especially if there might be a variable identified that we hadn't really previously focused on. I mean,
yeah, I think it's an interesting opportunity to, not only identify the big variables that will impact pellet quality, but maybe some of the smaller ones as well. And, the interesting thing with being able to model a very complex kind of response surface with some of these algorithms is also being able to model how those variables interact with each other. So my postdoc's working on another version of the model right now, from the trowel mill, looking at not only all of the individual variables, but also doing some what we call feature engineering. So looking at, for example, looking at the delta or the change in temperature across, say, the top to the bottom of the mill. So kind of engineering some additional, differences or products. So how does, conditioning temperature interact with, the starch content of the diet and these kind of things. So I think it also lets us examine across this complex response surface how these variables interact with each other, because it's not always going to be as straightforward as you might see in a single experiment that changes one thing at a time, right? In a mill, there's many things that are changing, so it becomes more complex to really know how to optimize that system, for a specific desired pellet quality.
What is your dream of how this could be used commercially? Could you develop, a tool people go online and they enter information, or is this a program they would run on site and it might help say, well, today you might need to do XYZ because pellet quality is predicted to be like this, but you change these variables and you'll improve it. What's your big dream?
I absolutely want to see these models used in practice to aid decision making. I think there's lots of ways in terms of implementation that we haven't quite gotten to yet, but that we can kind of imagine. I mean, at its core, this is Python code, which, for companies with programmers in it is great and is exactly what they want. But maybe for people who are working on formulations or are working in the mill, it's about, having an application where you can put in your formulation and your, typical manufacturing conditions and get a predicted PDI. What we would actually like to do is kind of flip it upside down and say, this is the formulation. Do we expect to see any problems with pellet quality? And if so, how should we change the manufacturing conditions? So essentially saying we want at least an 85, say, of pellet quality for this formulation. How should we change maybe the manufacturing to get it there, right? So to kind of flip it from being able to predict pellet quality to being able to say, yeah, this is the pellet quality we want. How should we change? How we manufacture it? And pie in the sky would be even great to embed such a tool like right into the feed formulation software, so that as the formulation is being developed, we get a predicted pellet quality that goes with it, and maybe a set of recommended manufacturing settings to go along with it. That might be a much downstream, but that might be a downstream way to implement such a tool.
Yeah, it's just the next version, right? It's like the iPhones. We're on 16.
Yeah, exactly.
Well, are there any kind of big ideas or anything that we did not touch on that you wanted to make sure we're clear before we wrap up our talk today?
No, I think we've touched on it. I think, yeah, for me, this is a really exciting project. I like it because I think it has, a good opportunity to kind of be implemented in a commercial setting with relatively little pain. And I think it's a really it's a nice niche for something like machine learning to occupy. I mean, machine learning is not faultless. It's just math and algorithms. And if we, for example, look at how well the model has performed so far, it's done well, but it's not perfect. And so maybe this is an interesting point to mention here as well too, that with doing this kind of research in a commercial setting, we are limited to the variables that the mills are collecting in practice. Sure. And so I think there's a few things that we know impact pellet quality that we don't necessarily have access to in the commercial setting. The one big one that we don't have in our models to date, but that we're looking at incorporating in the future, is particle size of ingredients, which we know impacts pellet quality, but is not as commonly measured in a commercial setting. We do have some access to this data, and so one of GHOW's next steps is really going to be to see if we can incorporate this information and how much better does it allow the algorithm to predict pellet quality. So those are some of the few things that he'll be busy with for the next year and a half.
Yeah, that's awesome. Well, before we wrap up today, I want to ask you the questions we asked all of our guests.
It's time for our famous three. Natural Biologics is using cutting-edge science to dig deeper into the poultry health challenges you face. By gathering scientific evidence, they identify the most effective combinations of natural ingredients that improve animal health. Visit naturalbiologics.com/poultry to see the newest research in both turkeys and chickens.
And the first one is do you have a favorite poultry resource that you use regularly in the work that you do?
So it might not be a poultry specific resource, but I think a lot of poultry scientists and maybe just nutritionists in general in the animal agriculture sphere are really interested in machine learning. So there's a really nice paper by Greener et al. In 2021 called A Guide to Machine Learning for Biologists, which I think is a really nice place to start if you want to really understand a little bit more about machine learning from the perspective of a biologist and not a computer scientist. So I think that's one that I send all of my students to as a starting place, which is probably one of my favorite papers to send them to. So maybe I'll send the listeners to that resource as well too.
Yeah, that's awesome. I think few of us want or have the ability to go take a whole class on this. So we like the cliff notes. So these are perfect.
Exactly.
Yeah. The second question is do you have a favorite non-poultry, or in this case, I'll say non-work related reference?
Yeah. It might not be non-work related, but another one of my favorite books, which actually when I came to my academic position, the dean recommended to me, and now I recommend to all my students, it's a book called Deep Work by Carl Newport. And, I always think in this kind of era of we're very tuned into devices and alerts and all of these things that it can become really difficult to do focused work. And so this entire book is on how to carve time into your schedule for meaningful, deep work. And so I also recommend that one to all my students, which I think is a really nice resource as well.
Yeah, no, that's great. That's one I'll have to put on my list. So good. So my last question for you is, What is your best advice to be successful as a professional in the industry?
Yeah, and maybe I can apply it in particular to kind of this digital boom that we're really having right now. And I think it's something that I really learned when I was in industry, which is that, as we develop digital tools and models and things, start from the problem. Don't start from the solution that, machine learning or AI or any kind of modeling is the answer to everything. It's not. It's good at some things. It's not good at other things. But start from a problem first that needs solving in the field, and work backwards to figure out what the right tool is. Don't start from a love of the tool and apply it to everything. That's probably my advice, I guess.
Yeah, I mean, heck, that is great for so many areas, not even just work related, it's life related. Well, thank you so much for chatting with me today. This is great. And I think there'll be a lot of really good interest in the topic. So thank you for your patience in explaining the differences to me. I really appreciate it.
Yeah, thank you so much for having me. I really enjoyed it.
Yeah, you're welcome. It was great.